section 6.5 is going to be analyzing and sketching graphs. This one's going to be a little bit differently done because I'm not going to give you your normal notes like I normally would, because what I really want you to do is to use common sense when answering these questions. So I actually would like you to go through this, and you're going to work with a partner and you're going to try to answer these questions on your own. And we're trying to figure out basically this essential question: how can graphs represent relationships between quantities without using numbers? In other words, can a graph tell us a story of what's happening? All right, that's kind of where I want you to look at it. So I'm not going to read any more on this. I want you to actually pause the video now, and I want you to try these questions on your own, okay? Please do this on your own first, okay? I would like you to spend the entire class doing this, and then after which, why don't you come back and finish this video up, because I will go over these questions and show you how things can be interpreted. That's not even a word, interpreted. So, pause the video now, try this on your own, this whole worksheet on your own, and then when you're done, let's get back and we'll talk over each question. All right, so this first one, it says, how is this graph different from other graphs you've studied? Well, first off, there's a couple of things that we could say. One, there's no numbers. Okay, that's the first thing that we can say. There's no numbers. The other types of graphs that we've studied this year have been linear. This is a nonlinear graph, okay? And that's basically it. They're different. It's nonlinear, and it has no numbers. All right, then it says this: write a short paragraph that describes how the water level changes over time. So notice how the graph has time increasing in this direction, and the water level increases in this direction. So let's kind of look at each individual piece. From here, it's a constant level. It's constant. A constant level. And then we have from here to here, we have an increase of water level. All right, so it's an increase. And then it levels off to get another constant level. All right. And then we have a decrease. Okay, so when we look at it, we can write a short paragraph, and I'm going to just kind of do this out loud. I start at a constant level, and then after a period of time, all of a sudden my water level increases steadily. Notice how it's steadily increasing. And it levels off at a maximum peak, and it levels off for a certain period of time. After time, it starts to decrease back to its original level, and that's when our time stops. Now, what I basically said, it could be any type of paragraph that you may have written. I'm not writing this down because we can interpret it multiple different ways. So after I've kind of got an idea of what's happening in this graph, it tells me in B that it wants me to write a short paragraph. Well, for the sake of time in this video, I'm not going to write one with you, but I am going to describe what's happening. We start at a time at a water level. We start at a constant water level. After a certain period of time, which we don't know, the water level begins to increase at a steady rate. Notice how it keeps going at the same pathway. After which it levels off and stays at that higher level for a certain period of time. Again, we don't know the time. After that time has passed, the water level begins to decrease at a constant speed, and that's where our story would end. So that's basically the concept. So what situation, for number C, can this graph represent? What real-world situation could we start at a water level and it increases to level off and then decreases over a period of time? Well, I would probably say something that we're all used to might be the river flooding. a river flooding. That happens during hurricanes. We have a river, the water level is constant. During the hurricane, it just increases drastically where it levels off for several days, and we know the damage that it can do. And then after several days or weeks later, that water begins to subside. So this is a story that we could create. All right, so let's look at number 2. I have a series of different things here, and I'm going to have to flip back and forth. I have speed and time. Notice that all of them. So in this particular one, I have an increase of speed. All right, I have an increase of speed, and then it has an even more increase because it gets steeper. So I'm increasing my speed over time, but all of a sudden, it just gets really steep. Notice how it changes. It's all of a sudden, my speed is increasing faster over time, and then all of a sudden, I reach my max peak, and then I have a decrease. All right, so that's what happens in this particular one. Let's look at the next one. B, basically, I start with a constant speed, then I have a decrease. All right, and then I have an increase. Okay, let's look on the back side of this. C, I start with an increase, then I have a constant where I level off, and then I have a decrease. And then lastly, look at this one. I start and I have an increase, and then I had a sudden decrease where I have a constant basically at 0. I'm not even going anywhere. My speed is nothing. So it's a constant speed of nothing, and then I have another increase. All right? So these are the basic concepts. So now let's look at these things and see which one of these makes sense. It says, you gradually increase your speed, then ride at a constant speed along a bike path, then slow down until you reach your friend's house. Well, if we look at that, it doesn't really make any sense until we look at this one. It says this, I gradually increase my speed, I ride a constant speed, and then I slow down until I reach my friend's house. So that actually would match that particular graph fairly well. Let's look at the next one. B, you gradually increase your speed, then go down a hill. You then quickly come to a stop at an intersection. All right, so it comes to a stop. So it says I'm gradually increasing my speed, but then it says I go down a hill. Think about that for a second. What happens when you're on a bike and you go downhill? You get faster. Hey, that reminds me of a particular one that we did before. I'm gradually increasing my speed, and then I got faster. So I went downhill, and then I came to a stop at my friend's house. So this particular one would match up very well with A. All right, let's look at the next one. C, you gradually increase your speed, then stop at a convenience store for a couple of minutes. Okay, you then continue to ride, gradually increasing your speed. So my choices now happen to be B and then happen to be D. So this one's a little bit confusing because if we look at both of them, it says you gradually increase your speed, which I do on D and I do in, wait a minute. You know what? I looked at that wrong. Check that out. This is a constant speed. I apologize. So really the answer of this one would be D. It makes sense. You gradually increase your speed on D, all right? Then you stop at a convenient mark. Well, that makes sense because in order for you to stop, you have to slow down, and then you stop at the convenience store so you're not going anywhere for a couple of minutes, which is at 0, and then you go off again. So that would be D. That means that the last one must be B, but let's look at it. It says you ride at a constant speed. You go uphill. Once on top of the hill, you gradually increase your speed. So, look at this. You ride at a constant speed. You're going uphill. Well, think about it. Even though this looks like it's going down, but think about it. When you go up a hill on the bike, your speed begins to what? Decrease, because you're moving slower up that hill. So you're going at a constant speed, you're going uphill, causing you to slow down, and when you get to the top and you start going back, it says this: you gradually increase your speed again. All right, so that last one would be B. All right, let's look at the next activity. All right, it says the graph represents the heights of a rocket and a weather balloon after they're launched. So we have graph A, where we have time and the height above the ground. So notice how it just kind of increases pretty quickly. This, by the way, is what we call, and this is something you'll learn in Math 1, it's called an exponential growth. And this is nonlinear. All right, and then we have graph B, where we have the time and the height above ground is at a steady rate. All right, so this is linear. All right. So it says, how are the graphs similar? Well, this is pretty easy. They're both increasing over time. They're both increasing our height over time. How are they different? One is a steady rate. So like graph A is not steady. It's nonlinear, okay? And then B, we would have a linear. So this, whoops, that's not very good. It's linear. So think of it this way. This B has a constant rate of change. All right? The next one says to compare the steepness of each graph. Well, if you look at it, this is, I would say that on A, it doesn't really start off as steep, but its steepness gradually increases, meaning that over a period of time, its height increases. So I would say that in A, the steepness changes, all right, over time, because if you look at different individual points, it's a little bit steep. It's steeper here than it is here. So steepness changes, all right? And that's also why we would call this an exponential function. And then for B, the steepness is constant, all right? It's going at the same rate, all right? So we have a constant change here. And then it says, which graph do you think would represent the height of a rocket? Explain. Well, I'm going to help you out on this particular one. I want you to think about a rocket and what a rocket does. When a rocket blasts off, it kind of starts off kind of slow. The initial blast just gets it up. But over time, very quickly, its height increases exponentially. So think about it this way. When I'm blasting off in a rocket, my time takes a little while for it to get off the air. Once I get it up in the air, I get a little bit faster and my height begins to change. And then as it continues to go and continues to getting higher and higher to the Earth's atmosphere, all of a sudden, the reduction of gravity and all that's wonderful things, all of a sudden it just goes away and all of a sudden it just shoots off, literally, forgive this pun, like a rocket. And it starts slow, but after it starts to negate the effects of gravity, it's going to get farther and farther. So for this particular one, I would say that this would be A, all right? Now, let's go to number 4. All right. The graphs represent the speeds of two cars. One car is approaching a stop sign. The other car is approaching a yield sign. All right. So in this particular case, notice that this would be I'm going down, just like both of them. They're both going down. So we are seeing a decrease for both. All right. So that is how they are similar. Decrease for both. All right. And then, how are they different? Well, A never stops, okay? While B comes to a stop. And I'll prove that to you. If we were looking at A, notice how it's got a speed. It's pretty high up here, and it slows down over time. But its speed never stops. It keeps going at this speed, so it just continues on. However, if we look at graph B, it starts here and it decreases, but the speed all of a sudden reaches to 0, meaning that it stops. All right, so it says compare the steepness of each graph. Well, I would say that graph A starts steep, but levels off. Okay? And B has a constant steepness. Okay? C, which graph do you think represents the car approaching the stop sign? Well, for this particular one, I would say B. Here is my reason for it. Notice how a while ago in A, we see that the speed actually does not go all the way to 0 for graph A. All right, but graph B, it does go all the way to 0, meaning that the vehicle stopped. So in graph B, you can tell that the speed came to 0, therefore the car stopped. All right. Questions 5, 6, and 7 are basically your own words. So 5 says, how can you use a graph to represent relationships between quantities without using numbers? 6, it tells me to describe a possible situation represented by the graph shown. And 7, sketch a graph similar to graphs A in activities 1 and 2 and exchange graphs with a classmate. Describe a possible situation represented by the graph. Discuss the results. So in these particular ones, questions 5, 6, and 7, I actually do want you to do these on your own. And I want you to show them to me. Show me what you've got. Show me your answers. And if there's some discussion that we can have, we will definitely have that. And that's it for this particular chapter. There's going to be a little bit more working with 6.5 over the next day or so. We're going to look at some more graphs and just get into it. And that's it for this video, and I'll see you in the next one. Bye-bye.